Okay, day 4 probably. I will remove duplicates. I'll do an easy one first. Okay, majority element. The majority element is the element that appears more than n over 2 times. You may assume that the majority element always exists in the array. Appears more than n over the floor function. So then, okay, and then in this one, 1, 2, 3, 4, 5, 6, 7. So it just has to be more than half or greater. Okay, so it has to just be half or greater than half. Okay. Let's see. This one, I guess. I can use a hash. I can assume that the majority element always exists. Okay, so okay. Okay, it's none for now, and then so for I in range len. For I in range not len nums. Majority count equals to 0. So I can just do equals to nums 0, and then the majority count equals to 1. For I in range this, if nums I equals to majority, then we just do, then we can just do count plus equals to else. Wait, no, but that's not gonna work. How am I supposed to figure out if it's greater? It's not sorted. Okay, well, I can sort it first, and then I'll do it. What else can I do, though? Can you solve the problem in linear time and O of 1 space? How the heck do I do this? O of 1 space, meaning I can use variables to store stuff in. Oh, I'll do that later. Let's just try and figure out how to store it. And then for I in range len nums, if let's see, How do I use Python dictionaries again? Wait, Python extract it's just in. How do I? You may assume that the majority element always exists in the array. Okay, let's just do a simple. For I in range len not in linear time, so I'm just looping through the array then. You may assume the majority element always exists in the array output. Guess I can use a dictionary to store the number. Use in. Okay, so if numzi is in dict, then we just do dict numzi else dict numzi equals to 1. And then here I can just return the one with the greatest count. So I can do get values, and then we can do values equals to dict dot. And I can just return the largest number in this. So largest equals to. Okay, and then we just do for I range. Then values, I can just do values 0, and then if values I is greater than largest. Oh wait, no, but that's not gonna work. It's just gonna tell me which one has the largest value. It doesn't tell me. How do I loop through a dictionary? Okay, so for key in dict, and then we just do largest equals to 0. Largest equals to we can do largest count equals to 0 if dict key is greater than largest count. Dict key is equal to largest count, then we do largest val. Largest val is equal to key, and then we can set largest count equal to dict key. And then in the end, we just have to return largest val. Okay, and then submit. Okay. This isn't probably very efficient, I guess. What's the complexity of this? Okay, this is O of n efficiency. But how can I do it in O of 1 space? O of 1 space. So I presume I need to just loop through it somehow. All one space loop through it. So for I in range len noms, I'm gonna have to loop through it somehow, and then I can probably do largest val is equal to noms 1 or something, most likely. So I need to how can I do it in O of 1 space? O of 1 space. Can I just search maybe half the array then? Let's try a test. How do I add a test case? Do 1 1 2 2 2 1, something like this. Oh no, something like this maybe. So here the majority is going to be 2. If the majority is 2, how can I figure that out with a single pass through the values? pigeonhole principle, maybe? Because we know that if number appears more than half, it's guaranteed to appear in either half of the array. Can I exploit that somehow? What can I do to figure this out? No, it's possible to solve it in O of 1 space. O of 1 space, so I only need like a few tracker variables then. Tracker variables 3, 2, and 3. I obviously can't sort this without it taking n log of n, so it's not going to be sorting. What is it going to be though? Surely has to do something with the structure of the array. What if, is it 2 pointers maybe? What was this one here? Okay. How would this work? So let's say I take this, put it in here. We know that it's 2, so, but how can we algorithmically determine that it's gonna be 2? If it's all, it has to be in place, right? There's no way you can do it out of. And what if it's going to be a case like something like this? What do we do if this happens? How are you supposed to 1, 2, 3, 4, 5, 1, 2, 3, 4? How are you supposed to know which one's which then? I don't know. How do you do this one? Floor algorithm though. What can I? If I had a third number, then it wouldn't work. 1, 2, 3, 1, 2, 3. So how can I figure this out? Let's take a look at the solution, I guess. How do I do this one? You use the same idea of this, but actually we don't have to use a hash map. Two variables, res and majority. Every time the current number is the same as res, we add 1 to the majority. When majority is 0, it's time to change. That means a current majority. Oh, okay. So we have value and then we have the count equals to non-zero. For I in range len nums, for I in range lem ones, if nums I is equal to value, then we do count plus equals to 1. Plus equals to 1, else we do count minus equals to 1. And then we do if count equals to 0, then we do value is equal to nums. We do value equals to nums I because say it's 2, 3, 3, 3 like. So say it's oh, where did my stuff go? 2, 3, 3, 3 like this. So if we start off over here, So the current is going to be this 2 and count is going to be 1. Set it here. If it's not, move it to the start. Because if it's equal, actually it doesn't matter, because this means that there exists at least one other number that has the same count as and then we go to the next one. And then we can just return balue. Oh, whoops. What do you mean there's no majority element? Okay, so what happened with this test case here? So you set it equal to 1 first. So there's plus 1. It's 2. Minus 1 minus 2. Do it at the start of the iteration. Now let's try it. There's still no majority element? So this is 0. Let's try it now, maybe. You need the count equal to 1. Still no majority element? What? So this is 1. So 2 minus 1, so that's 1. 0. Checks that it's 0, so then we change the count to 1. 2. We do a -1 here. Shouldn't this work? Huh? Am I being stupid? Oh, appears more than, so this case just straight up doesn't work then? I'm so fucking stupid. Okay, whatever. The test case was wrong because I'm... Oh, okay. Okay, it's alright. 3 millisecond submissions. Still takes the same amount of memory, but the runtime is faster. Okay, cool.